Hi everyone, I'm Nicole Harris.
And I'm Kali Tessier.
And this is our podcast,
Between Two Fans. So today's guests are Scott Miller and Nick Heymer. Can you guys describe your roles at Horton and maybe how long you've been working in those roles?
Scott Miller, I work in research and development, and generally, I'm working on tough applications. We can't necessarily take an existing fan and apply it to something else or a blade. It's kind of like new, different blade shapes that we don't have. Kind of some of the tougher fans as well. Those are the ones I typically work on. How long have I been here? So when I started, I used to have to bring in $1 every day to get my pop, cash.
Nice.
Like that was a long time ago.
Yeah.
Couldn't just
They
swipe
had
the
a
credit
pop
card.
machine in the little room down there. And most of the days I'd forget my $1. So I'd always have to go around and find money from someone, Dave
Yep.
Benson and Eric Raw were the big ones who would always loan me some cash.
That's so
Chatting
nice
with
of
you
them.
Once in a while. I've been here for 15 years. Also, that was before rising desks. And
I like
No
my
standing
standing
desk.
desk.
no standing desks.
Wow.
So, and before chairs that rocked.
Wow.
Yeah.
Okay. The dark ages.
Enough about me.
Nick Heymer. I'm the senior advanced manufacturing engineer. I guess all that really means is I work with these yahoos from design and R&D, and I say, no, we can't make that. This is how we could make it, and then I work with the plants to actually make the things that these guys dream up. That's probably the easiest way to say what my job
I'll
is.
tell
think
you,
that's
you
a
give
good
us more of a
description.
green light than I've ever had.
Yeah, I mean, it's like, we could probably do that.
Yeah.
It's just going to cost a
Yeah.
lot of money. But yeah, no, that's basically what I do. And I've been doing it for almost 4 years now.
Nice.
How often do you get to fly to the plants and work there?
I mean, when I was setting up a Coney, it was like every other week, but now it's like maybe once a quarter. So, but I do a lot of other stuff. Like we're working on our E-fan
Oh, that's fun.
Fun.
every once in a while to work on that stuff. So.
Have you guys always had the role you have now, or I'm assuming 15 years you've moved through different roles?
I'm in the same one, but he's
Okay.
had a few.
I've had a few. I came in as like a design engineer,
Okay.
and then I worked in there. I think I went up senior design engineer, and I was engineering manager for a while. And I was like, at that point in time, I was like, not really right for me. So I kind of stepped back and went to the research, the R&D role. I kind of enjoyed the technical stuff more.
Yeah.
That's
Okay.
nice.
Cool. So we'll kind of get into you first, Scott. So what are some of the design considerations for when we're making new fans, designing new fans?
It's always so you kind of start with like brand new fan, okay. So,
Yeah. Or I guess if you had to alter an existing one pretty
Sure.
significantly.
Customer comes in, it's always like, hey, what speed are you operating at? What's your shroud type? What's your immersion? What's your flow pressure? And then you kind of take it from there and go try and create the most efficient fan you can after you hit those points. So
Okay.
So how often are new fan projects driven by the customer versus internal through Horton?
I mean, always right, because we're not just making fun stuff,
Yeah.
making stuff to sell,
Yeah.
It's and it's it's kind of Horton's thing, if something comes in, we tend to make a lot of different fans for a lot of different people. So yeah,
That's true.
yeah,
Very true.
there's a lot of different variations.
And a lot of it's modifying existing fans, right?
Most of it is,
Yeah.
and that's actually what I try to do first before I do
Yeah.
this whole other thing. I'm I'll try to figure out or me or Nick or whoever will try to figure out well, can we use an existing fan even before we do new blades? I'll be like, can we just scale an existing fan we have because we know the blade shape because the risk is a lot lower and the time commitment's a lot lower as well.
Yeah.
Yeah, I'm working on some fans with some customers who are just scaling some. It's a new prototype fan, but it's scaling down of some of our existing blades.
Yeah.
So what type of validation does the design team kind of need to go through before you can go to Nick's group and be like, hey, can you help? Is this manufacturable?
So we'll typically take it through the FEA programs.
Yep.
We do a couple different things in there. We'll do a burst simulation, then we'll do fatigue simulations, stuff like that, and we get a good feeling for okay, we think this is pretty good. Go to Nick's team.
Yeah. And there's a standard template that they run through too, and they fill it out as we go. And we're always involved from the beginning too, to just kind of give them some general feedback when they start designing stuff. That hub is way too tall. We're never going to be able to mold that, or some general geometry stuff even before they bother to run FEA. So we start right at the beginning.
Yeah.
But yeah, once they get way down, then we actually take a serious look at how we're going to build it and all the manufacturability after they've run through that kind of design template.
How do you guys determine like certain fan limits, like tip speed limits, like how big we can make our fans? I suppose how big would be a huge manufacturing
Yeah.
thing.
Yeah, that falls into it sometimes too, but we have a pretty standard range that we fall into for molding, and then they determine all the rest of the stuff.
Okay. So how do you determine like tip speed, like temperature, soak
I
temperature,
mean,
all that
tip
stuff?
speed is always, I think it's kind of been this, it's been around for a while. It's doing burst tests is typically what we're going to do to determine the limits of the fan.
Yep.
And also do fatigue testing of it too, A lot of times you have to do that in vehicle too, I mean, you
Yeah.
do some stuff here to figure out how long it'll last, and then you do stuff in vehicle to make sure it's below the different strain, stress levels, whatever, to last in the application.
Could you elaborate on what those tests are, just for people who don't know?
Your DVP and our stuff. He's never done any of them ever.
No, it's just like the fatigue test is you basically rotate a fan, and you put up, think of bars across it.
Okay.
You're basically disrupting the pressure loading on the blade, so it goes. So you're trying to make the blades go like this during the tests to stress them out.
Okay.
Okay.
Yeah. Burst is
Simply as it sounds.
too bad. It'd be like queued up, boom. You'd hear it up here.
Yeah.
Yeah.
It'd shake the floor when you burst a fan. So kind of is what it is. You turn it
Okay.
as fast as it can go in a vacuum, and you let it break and
If it'll break.
see where if it'll break. Yeah.
Some of them
see where
don't.
it go.
Yeah, some of the little ones don't. We couldn't break the E-fan. Couldn't
Oh.
spin it fast enough.
Really?
Yeah.
Wow.
Yeah, that's a tough little guy.
That's good news for the customer, I
Yeah.
guess.
Well, yeah, I mean, you could never spin it that fast anyway.
I feel like the first project coming out of this meeting is going to be cost reducing that fan.
Yeah, right? Yeah.
So we have a lot of different materials that we use for our fans. What are some of the different materials that we use, and why did we choose those materials?
Right. So earlier I mentioned that we have a thermoset and a thermoplastic. And most of our fan portfolio is a thermoplastic. And we use like a glass-filled nylon across all of our plastic fans. And that's, basically something that can be remelted, recycled. We don't use any recycled plastic because it does change the properties as you go. But a thermoset is like what our H-Tech material is made out of, which is like a fiberglass composite. And you can't recycle that or break it down or heat it up to deform it. It's why we use it in our H-Tech blades because it's so tough.
Very durable fan. So when it comes to actually manufacturing some of these fans, out of any of the different types of fans we make, what would you say are some of the biggest manufacturing challenges?
Ooh. I mean, it depends on the fan. And the fan style. So like ring fans are pretty tricky to make. Those are popular in our European customers, but like when the ring kind of meets on the outside, that's a pretty big weak point, and it's hard to design your injection profile to get that knit line to meet up on the outside. That's one of the trickier things when it comes to manufacturing. But then there's challenges with everything, from like blade size, getting it to fill out in the ribs, like on our HS11s, that honeycomb structure.
Yep.
Some of that stuff's pretty tricky, so we like to work with the design guys up early to make sure we design the thickness of those right so we know they're going to fill out. What else? H-Tech is a little bit tricky too, since it's not a traditional thermoplastic, it's a thermoset, and we compression mold those. Those we don't really have too much trouble with. It's a known thing. Not too much from the manufacturing side on those. But yeah, they're all a little bit different. They all have their own challenges. But we plan ahead.
Making sure the material goes the right ways.
Yeah, exactly.
You get the glass fibers
Yep.
oriented correctly.
Yeah.
Yep,
Right.
all that good stuff.
Yeah.
Which fan is the easiest to manufacture, and which ones would you say is the hardest to manufacture?
That's a tough one.
Putting the screws to it, man.
Yeah, I know. She's killing me. Well, the easiest ones, it depends. I mean, they all have their challenges. Some of the metal stuff is more complicated when you get into like rolling blades and riveting them together. H-Tech is actually pretty easy because all you do is huck it together, basically.
Yep.
But they're big and unwieldy, so they take a little bit of extra time and care to get those just right. But I don't know. Shogun's pretty easy to mold. It's all automated. It's basically lights out. You can load and insert. Robot does the rest, and you get fan blades out the other side and rivet them together. So.
What about the new MSA blade tools?
Oh, that one was real fun. Had to make 4 tools to get that one right. But we got it. That one was challenging, yeah. Yep.
What are some considerations you guys have when you're designing these tools and like molds and stuff?
So just like when they do a design for the actual like fan blades, we have a template that we follow that we kind of run through when we do a new mold. So we'll take the data from these guys and we'll run it through mold flow, which simulates injection pressure, time, cooling, all that fun stuff, to kind of figure out how we want to design the cooling channels in the mold, which side we want to load the center disc on if it's an overmolded center disc, and how to like eject the fan and catch it with a robot. And we do all that planning ahead before we ever cut chips on the tool.
Okay.
Yeah.
I feel like the
it's
robotics
process.
is like the cooler side of molding,
It is
isn't
pretty
it?
cool. Yeah,
Like
yeah, it's fun.
grabbing the parts,
Yeah.
put them in, and
It's pretty basic though. I mean, we don't do anything real
don't sell
fancy with
yourself
those.
short here.
Well, I mean,
You know?
the real fun stuff are the Fanic robots that like unload everything.
what
and
robots?
Do the yellow ones. The yellow
yellow
robots.
The Fanic?
Yeah.
Is that the? Did you name them that? Because they're dealing
No,
with
that's
fans?
like the brand name.
That's the brand name.
Yeah,
okay.
yeah. But those are the cool ones because they like grab, a cooled fan and bring it into the laser marker and
that's
stack
fun.
pallets, and those are the fun ones. Yeah.
I feel like we should name our robots. I feel like
You
that'd
could.
be. I feel like that'd be fun.
I have a question about the
They gotta be
robots.
What?
basic names though, like
When
Fred
they
and
when they
Greg.
come in, are they already programmed to do what you want them to do, or do you have to write the code for them to do it?
So we do it a little bit of both ways, where we have like an outside automation company take care of the real
Okay.
big, like complicated setups of an automation cell, and then our engineers at the plant are able to tweak those, add new programs, modify little points at the ends of them.
Is that it? Like a manufacturing engineer? Is that like
Yeah.
a computer engineer?
No, that's typically a manufacturing engineer.
So you guys know how to do all that?
Sometimes a tech. Yeah,
Really?
yeah. I used to previous life.
Your stock just went up in her book, man.
I found that to be like I would have
used to
never thought that
program
for
them.
manufacturing.
Yeah, it's fun. You get to play with robots.
That's
Who
true.
doesn't
I'm
wanna
with
do
you.
that?
I
When
know
you-
manufacturing guys
I'm
so
like
to do
just
that
not
together.
good at coding though. That was like the hardest class for me in college.
It's not really coding. It's more of like teaching on a pendant.
So how did you learn how to program these robots?
So I learned on the job, and there's like a Fanic training class. There's for any
Okay.
type of robot where you
so
can
like
go
it
and take
could
a.
it could teach us
Yeah,
almost.
it's not hard. There's
Even
easy,
you
like
could learn it,
1-day
Nicole.
classes, or there's like
Oh.
week-long classes. So
I'd probably need the week long.
yeah,
It takes a while for me to get the
We
coding
can
right.
get those robots to help us
Yeah.
slouching, man.
yeah. There you go.
Okay, so when I work with customers, some of them want like their logos on our fans or like their part numbers on our fans. Is that stuff you take into consideration when you're designing the tool, or is it something that you need to go in and modify the tool afterwards?
Yeah, it depends. So if it happens up front, the design guys will put it right in the CAD file, and we'll take into account, like, we'll make it an insert when we build the tool to change between, like, a Horton logo or a customer logo. That's pretty easy to do. And if they want it after the fact, sometimes it's a little bit trickier. We have a few options where we can do, a lot of times they get their own label with their logo on it, and it still has the Horton logo molded in. We also, don't tell anybody, we have some pretty fancy lasers. We could probably laser a logo on if we really wanted to, but we haven't gotten around to that yet.
Who doesn't want a laser?
I
logo
know,
on?
it'd be really cool. We could put like polar bears everywhere.
Oh, I so would be up for that.
Little Hermans all
That
over
would
our
be
fans.
so cute.
Yeah. You test that out.
Imagine like little Hermans on each of those little blades.
And then imagine them rotating at like
Yeah.
2,000 RPM.
You wouldn't even be able to see
I
them.
know.
If you
Let-
did it right, you could like make them move all
So-
the way
I
around.
know,
Yeah, it
yeah,
would be
yeah.
like
That'd
one
be
of those
so
flip
cool.
stories.
The original TV.
That would actually be sick. That would be really cool.
We could probably come up with something like that for a marketing ploy.
At
Oh boy, I just signed up
L'Oreal.
for it, didn't I? Oh well.
Marketing is shaking their head no off
Yeah.
camera.
What makes Horton unique in the sense of fans?
I mean, we'll make custom fans for our customers. It's generally
Yeah.
it's like, hey, we want this fan. We'll make this fan for you. I think a lot of times, other companies get really wrapped up in resources and all this different stuff, but it's just kind of Horton's gig. It's like, hey, you got something tough. Like that's what we do is we solve it. So
Yep.
Yeah, it's fair.
Just sometimes you not like that being in manufacturing.
No, I mean it's really not a big deal. If
like,
you pull
why
a
did
part
you
number,
create this?
it's really easy to change the diameter and make something custom for a customer. But sometimes it does take a little bit more work if it's something more involved, like a different bolt pattern on the disc. We just have to try some stuff out. But typically, it's not too hard to come up with something new or custom.
Okay, so we make our largest fan we make is a 96-inch fan that goes on like mine trucks and stuff. What is the smallest? Do you guys know what the smallest fan we make? I know we make a couple of different small
We do have some
ones.
small ones. I know 508 I was just working on, which is 508 millimeters.
I think the E fan is
Yeah.
445 millimeters, I
Yeah,
would
which
say.
is only like 16 inches across.
Got a calculator. I could pull out a calculator.
It's a baby gap.
You know,
It's just a
yeah,
little
it's pretty
one.
small.
Yeah.
Yeah.
For the viewers watching, that's smaller than our rainbow metal fan
That's
over
true.
there.
Yeah.
Have you ever like dreamed up a fan that you thought was going to be great and like just didn't really turn out for a customer?
Yeah, I did. Yeah, one time. Doesn't happen often, but because our programs are pretty good, we usually get them right. But we had one fan for a customer where it was a smaller fan with a large tip clearance, and we kind of went all the way to a single mold tool, and it came in not quite as good as the current fan. So yes, we have had that. It was a weird fan because it like.
It was a weird application.
It wasn't a weird application. It was a weird fan in the sense of like the tip clearance was so big that like if you look at a fan curve for a given flow rate, the line went straight up.
Mm-hmm.
You know, like
It's not a
curve
curve.
typically
Smooth, yeah.
a curve typically right for one flow you get a certain pressure.
Yep.
For a flow you got a certain pressure range
Yeah.
that would occur. So it was really really weird, and that's like an experimental test curve that we were working off of too. So that was the one that got away.
Do you guys have any fun stories while you've been working with Horton?
No, I mean, it was fun. That was definitely different. I mean, moving a plant, having never done it before, but I kind of knew how to set up an injection molding shop. I brought a lot of experience there, but like having to place machines and like figure out your product, how it's going to flow through a whole factory was new and kind of fun to figure out. And Andy and I worked on that for months to get that locked down and got all the machines moved. So that was kind of fun, I guess, but nothing pertaining particularly to fans.
Do you have any other fun stories?
Probably like the one that's probably like the one where you're like, oh my gosh. So we're driving from, where were we driving from? The border in Mexico. We were doing a field test, driving to the port of Long Beach.
Okay.
And I was trailing behind a truck. It was like 11, 12 at night. I don't even remember. It's dark out, you know.
Yeah,
And
pretty
we're
late.
driving, and all of a sudden, like, I get a call from the guy who's in the truck cab in front of me. It says, we got a problem. And then the truck starts veering off a little bit and slowing
no.
down. I'm like, oh my gosh, what happened? We were doing a field test, and our slip ring let go, and we busted the radiator open.
Nice.
And I was like, and the guy's like, I got to get to the port, man. I'm like, well, let's go get some stop leak, and we're gonna go for it. And so we got him to the port, and we grabbed all of our gear and got out of there. But
Oh
he
my
got up and running. We got
gosh.
back. We ordered him all new parts and stuff like that, so he could get them installed.
Yeah.
Because the guy was nice to help us out in a field test, and so got him all new parts. But we got him to the port. But I was like, oh boy, how are we gonna deal with this? You know.
Oh, that's scary.
Yeah.
How far did you have to go after it? Like, after the slip? ring got
On a
off?
map, like, is about that much.
Oh.
So
Okay. So not.
So,
But like,
So not far, but far.
pretty small map, but
what kind of music do you guys like? Personally, I like heavy metal fans. I messed that up. I was supposed to say, personally, I'm a heavy metal fan. The moment's gone.
so bad. That's like a Kramer
I
dad
think
joke right
that's
there.
like.
I forget who
Probably
I heard
that
that one.
stays on there.
I heard that one from somebody
You
else.
didn't hear that from anyone. You came up with that yourself.
Yeah, totally.
All right? Yeah.
I definitely
Just
heard
take
it from
credit for it.
somebody at Horton. I just don't know who to give the credit to.
You heard
Kramer.
it from someone.
Maybe Kramer.
It's got to be Kramer. He's got the worst dad jokes.
Maybe.
You know he has a dad joke of the day calendar.
Of course he does. Oh,
Yes.
Oh,
He
that-
wakes up every
that makes
morning.
sense.
He rolls over, after he puts on 7 layers, he puts on his
he's
glasses
got to have sweater.
and reads his dad joke of the day.
Wow. Okay.
Sometimes they're funny.
They are
Sometimes
funny.
they're
I'm getting my
okay.
daughter one this year. Dad
Yeah.
joke of the day calendar.
Oh,
She thinks
great.
they're hilarious.
Heavy metal fan.
Yeah. You wanna plop that one up again? You wanna try again?
Is the moment gone?
They don't know you missed the moment.
Yeah.
After they
True,
edit it.
they gotta edit
Yeah,
it.
but now
After
you're gonna
they
get like
edit
a
it, they
fake
don't-
laugh
yeah.
or a fake groan.
I was gonna say, now Nick's not gonna do
I
his
know, I'm just
laugh.
gonna be like,
Try it again. Try it again.
So, what kind of music do you guys like? Personally, I'm a heavy metal fan.
Good job. There we go.
oh no, it's just as bad.
All right, thank you for watching today's episode of Between Two Fans, and thank you to Scott Miller and Nick Heymer for coming on and talking to us all about fans.
Tune in for our next episode of Between Two Fans.